As I told you, this does a automatic simulation for us. But before we go, let me just make sure we check. I make this bigger in order for you to see clearly. And if you were paying attention, the moment I was making the copy of this KB, the copy paste, the name didn't change, so I just changed it to be gain for in order to avoid misunderstanding. So well, and same way, we also forgot to define the V value, our voltage value. So I will define it right now, V, and register. So when you look at it carefully here, we see that we forgot to define the V value. So let's run it and see what will happen. Give it run and let's see. You can see it's busy, everything is okay. Let's see the scoop. Yeah, it's same. And when you look at the scoop here, we will see our output signal. Let me just, yeah, you can see here, this is our output signal. In order to understand and analyze this system better, we can also use a multiplexer, and we'll put it in this portion theta angle in order to see the input value and the output value, so we can make the comparison, so we'll know what is our desired value. So we'll see the exact point that we want the system to be performed in that way. As you can see, when I click on it, well, so you will see this is our signal. But the system is kind of pretty aggressive, but let me just use a multiplexer. After this one you will understand better, so we can see the difference. We'll see the difference between the input value, which is our step input signal, and the output signal, which is our motor angles signal. In order to do that, we have to wait until this program hand up. Then after, we'll just make a new implementations. Here, let's wait a little bit. My laptop is quick slow. Yeah, I think it's done. Yeah, finish. So let's use a multiplexer. Let's come to Simulink library and go to common use block. You can see this is a multiplexer. Control+I bring it for us. I'll just do it instead of dragging. As you see here, I'm going to move it here and cut this one, or maybe let me just take it out. No, okay, this is a mistake, so it should be connected here. Okay, and I'm going to move this one away a little bit. I will take one from here and come to the input value, and another one coming from here. Let me make it bigger for you to see. Yes, good. So we are good to run it. Let's run it again. It doesn't matter if you like, you can run it from Simulink, and if you like, you can run it from MATLAB, because they are both connected. And also, if we want it, we can also change this value. As you can see, the time, simulation time. So I will just make, I will assign sim time, and I need to define it. Remember, always if you define something here, you need to define it to tell MATLAB what is it in mscript file. So I'm going to make a copy paste same way, and sim times is equal to, let's say, 5. Okay, so this is simulation time, as you see. And if you like, we can also mention clear all. That will clear all windows and workspace for us before our job gets started, as you already know that in MATLAB. And if we also want it, we can also import it to the MATLAB Simulink, but I will do that later. Let's have an example on this one. Yeah, let's run it and you will see. I click on run, it should run. Yes. What's wrong? I forgot to register. That's the point. I need to register. You should always double check things. Sometimes it may get wrong. I think, okay, unknown variable sim time. Okay, let's see. I forgot to register, so that's the point. Okay, let's just run it from here. It will automatically register for us and run it. Let's see what will happen. Now it should be, yeah, it should run, as you see, without any errors. Yeah, sometimes just double check, because there might be some kind of few mistake you might done, you don't know. Let's see what is on the scope. As you see, we got the purple one, the input value, and the yellow one is the output signal, which is our wings angle position. So we see that here the system is kind of aggressive a little bit. We don't want the system to perform in this way. We want it to perform in better way. To do so, we need to control it with PID controller. So after this one, I want to show you another stuff which is different from this. We can bring the scoop actually to the workspace. I'll show you that technique after it just stopped running. Okay, I think it's stopped now. Yes, stopped. So to do that, we need to go to Simulink library, and as you can see, sync. It should be sync. Yes, as you see, to workspace, sim out. So we'll click on this one to drag and drop, or Ctrl+I, take it. As you see here, so we just need to define it. I will just use two of this one. One is for the input, drag and drop this one, and one is for output value. Okay, just connect it here. Simple. Let me make sure I rename this one. As I said, this is our input, so I'll just put in here. This is output, so just put out here, as simple. Now after that, let me register, because remember that was my mistake on last time. And now just run it and see what will happen. Before I run it, I need to define this value here. So I will say figure plot in that time in that data, and I will say hold before it does the other one, the next one, out that time, out that data. Once this get registered, we should be able to see this for datas in our workspace. So let's save it and run, or if you like you can just run it, it will automatically save it and run. Let's see now what is our as you see for the simulating part, but we are expecting it to bring out another figure from workspace. As you see here, it's busy, so let's wait a little bit. My laptop is slow. We should be able to see the same signal in MATLAB. So this is what we're seeing as before. If you like, we can also try to check out this stack mark. Max step, let's say this is 0.1 in order to see it clearly, our figure, I mean this figure here. You can see it's same kind of rate, so we should be able to see the figures here. In the meantime, let me just define this down. Output signals. Oh, it just come up. Okay, I will just write this one. Output signals. Okay, let me show you the graph. Yes, this is the graph that we were expecting it. Yeah, as you see, the system is kind of aggressive, so we'll try to control it with the PID. So let's define these terms as our plant. And then after we'll try to define the other side here. Let's define these terms. Our PID controller. PID controller. Then let's define our PID parameters here. Let's say KP. Then after we'll define it later. So blah blah blah. KD is equal. I'll just give it a random value so we can see. Is equal So let's say KP is equal to 5, for example, and KD is equal to 20, and KD is equal to 0.05 or 555, like that. Just we'll see. Then I will explain you before we go for this step. And let me come here. Thank you very much. I hope you enjoyed this part. In next video we'll do the PID implementation so you can see.